The exponential family looks like this as long as the base of the exponential is a number larger than 1. Things that we need to explain here are why are the points 0, 1 common? Why do larger bases yield smaller outputs when the input is less than 1? And what's happening with this asymptote at y equals 0? So as long as we're looking at inputs that are larger than 0, I think this is quite familiar. As the x values get larger, the y values multiply the previous output by 2. So a linear function had constant additive growth. Exponential functions have constant multiplicative growth, which just means that the growth involves constant multiples. The common point at 0, 1 is explained by the fact that any number to the 0th power is equal to 1. But why should that be the case? There's a couple of different reasons, but I think an easy way to see it is to imagine, instead of looking at the growth as you make larger inputs, imagine going in the opposite direction. So as my inputs go from 3 to 2 to 1 to 0, instead of the outputs multiplying by 2, the pattern would be I'm dividing by 2. So as I go from 3 to 2, the output divides. As I go from 2 to 1, the output divides. So it makes sense that as I go from 1 to 0, to follow the same pattern, the output should divide, and 2 divided by 2 equals 1. Here, 7 divided by 7 equals 1. And in general, anything divided by itself is going to be 1. If we continue this pattern into negative inputs, you can be reminded about the meaning of a negative integer value for an exponent. So if the input is -1, then following the pattern, I would be dividing 1 by 2 to get 1/2. And then I divide 1/2 by another 2 to get 1/4, and so on. So now we can explain why there's a horizontal asymptote at y equals 0. Just to remind you about a horizontal asymptote, the idea is that the outputs of your function are going to approach the y value at the asymptote, either as x approaches -infinity, so as the graph is going infinitely to the left, or as x approaches positive infinity, as the inputs are going to the right. In this case, clearly it's as x approaches -infinity. So why does it make sense? The more and more negative the input becomes, you can see that the output values are getting smaller and smaller and smaller, approaching 0. You're sure they're never going to hit 0 because they're always of the form 1 divided by 2 to the power of something. And it's not possible for 1 over 2 to the power of something to equal 0. Indeed, we know that it's always going to be larger than 0. And that also explains why the larger base should have smaller outputs when x is less than 0. Because here, when x is increasing, our multiplicative growth is multiplying the outputs by 7. Going the other direction, we'd be dividing the outputs by 7. So here we'd have 1/7 and 1/49. So for a given x value, say -2, a larger exponent is going to mean a smaller output because the denominator is going to be larger.